So we have a circuit with a light-dependent resistor in series with a fixed resistor. We're told the EMF and the resistance of the fixed resistor. The student moves a lamp towards a circuit and observes that the potential difference changes across the fixed resistor. And we're trying to explain why this is the case using or referring to the electrons in the LDR. So as the light intensity increases, the electrons in the LDR will gain energy and be promoted from the valence band to the conduction band. And when that happens, the charge carrier density increases. If the charge carrier density increases, you have more electrons that are available to go around the circuit as current, and this will decrease the resistance. So the resistance of this component goes down. And then because voltage splits in the same ratio as resistance for resistors in series, then if we consider 75 to this resistor R, if we know that R is going down, well, that increases the ratio in favor of this resistor, and therefore it will get a greater share of the 6 volts. For part B, when the lamp is at a fixed distance of 10 centimeters from the LDR, the reading on the voltmeter is 2.4 volts. So we have 2.4 volts there. And then if that's the case, we will therefore have 3.6 volts across the LDR because the two must add up to make 6 volts. And the question wants us to work out the resistance of the LDR at this distance. So if we use these two values, the voltage across the fixed resistor and its resistance, if we divide the two things, we end up with the current in the circuit, and that would be 0.032 amps. So from our cell, we have a current of 0.032 amps. That will pass through the LDR. We know the voltage of the LDR. We can then use the voltage and the current to then get resistance. So 3.6 volts divided by that current that we've worked out, and we end up with a resistance of 112.5 ohms, which is approximately 110 to two significant figures. So for part C, it says the student wants to modify the circuit so that the light bulb lights up when the room goes dark. So if the room goes dark, that means the resistance of the LDR will increase. We know before that a lamp was a distance of 10 centimeters away from the LDR. So if we're removing that lamp and then leaving this LDR in a dark room, the resistance will increase significantly. So it's now much bigger than what it was before. Before it was 112.5 ohms. Now the resistance of the LDR will be much larger. She modifies the circuit as shown below. When working normally, the resistance of the bulb is 3 ohms, and the voltage across it is 3 volts. So in order for the bulb to light up properly, it will need to have a voltage of around 3 volts across it. We're trying to figure out whether this will work in the circuit that we have, and to do that, we want to think about what will be the resistances of these individual parts of the circuit, and therefore how will the voltage split. So whenever you have resistors in parallel, the total resistance will always be less than the resistance of any one branch. So to break that down, let's think of an example. Let's think of an example where we have a 1 ohm resistor, and this is in parallel with two other resistors, a 1000 ohm resistor and a 1,000,000 ohm resistor. So all of these three things are in parallel. So let's think about what will the total resistance of these three be. If we were to actually work that out using our calculator, so using the parallel resistors equation, we will end up with the total resistance being about 0.999. Which might be surprising. You would think that if you had a 1 ohm resistor and you were to add a 1000 ohm resistor and then a 1,000,000 ohm resistor in parallel with that original one, then the total resistance will increase, because obviously these are very big resistors. But we find that the total resistance decreases, and we see that it is less than the resistance of any one individual branch in this set of parallel resistors. So why is this the case? Well, we can obviously see it from the equation, this phenomena in action, but what's an intuitive way to think about it? How I like to think about it is, imagine if these two resistors weren't here. So at the moment we just have current going through this one resistor, and obviously the total resistance would be 1 ohm, because that's the only resistor that we have. If we were to then introduce one of these extra resistors, so let's say we are now introducing the 1000 ohm resistor, so this is the circuit that we then have. So to begin with, current was going through this branch that we had, but now current also has the option of going through this branch. Now it will be a much smaller current that is going through the top branch. The resistance here is 1,000 times bigger, and therefore it will receive about 1,000 times less current than we get through this branch. But it is still an extra avenue for current to travel through. Before it could only travel through the 1 ohm resistor, and now some, although a very small amount, will travel through the 1,000 ohm resistor as well. And that will decrease the resistance. Similarly, if we were to then attach the 10 to the 6 ohm resistor, the same thing will happen again. We have an extra path for current to pass through, and that will decrease the resistance further, although even less than it did decrease when we introduced the 1000 ohm resistor. So how does that apply in this question? We have an LDR which has a resistance that is significantly greater than 112.5 ohms, and we have a 3 ohm resistor in parallel with it, and therefore the total resistance of these two must be less than 3 ohms. And if the resistance of the LDR is quite high, then that means that the total resistance of those two will be approximately 3 ohms, just shy of that. So then we have a 3 ohm resistor approximately in series with a 75 ohm resistor. Voltage will split in the same ratio as resistance. So if we're splitting 6 volts in a ratio of 3 to 75, we will see that the 3 ohm bulb will get significantly less voltage than the 75 ohm resistor. It wouldn't get 3 volts of voltage. The voltage will not split equally between these two components. That will only happen if the total resistance of this was equal to the total resistance of this resistor, which, as you can see, is not the case. So the circuit will not work as intended, and the bulb would be very dim, if on at all.